Assalamualaikum and good day to panel. My name is Muhamad Haziq. Today I will present on my research project entitled Effect of Empty Fruit Bunch and Glucono Delta-Lactone in Synthesizing of Xerogel based empty fruit bunch via oven drying on the adsorption of engine oil. In overview of this research, this paper shows the possibility of Xerogel as an adsorbent to replace non-renewable activated carbon. Xerogel is a porous structure solid gel which obtained from evaporation process of liquid hydrogel. Empty fruit bunch biomass is used as it has high cellulose and carbon content, which is very suitable as an adsorbent. Xerogel based empty fruit bunch is synthesized by internal gelation method. Xerogel was prepared by the ratio of sodium alginate, empty fruit bunch, glucono delta-lactone and calcium carbonate. The parameter of empty fruit bunch and glucono delta-lactone is varying to observe the changes in adsorption capacity, percentage shrinkage and physical structure of Xerogel. The problem which led to this research is the spillage of oil into land, ocean and river, which creates problem. Next is the inefficient technology and high cost in removing oil. As an example, chemical dispersants which contain toxic and carcinogenic substance, as well as a flammable substance. And the objective of this research is to synthesize Xerogel based empty fruit bunch (EFB) via oven drying with effect of empty fruit bunch (EFB) and glucono delta-lactone (GDL). The second objective is the resulting of Xerogel is characterized by using scanning electron microscopy (SEM), Bruno Image-Taylor (BET), Fourier transform infrared spectroscopy (FTIR), thermogravimetric (TGA) and X-ray diffraction (XRD). Last objective is to investigate the adsorption capacity of engine oil and the percent shrinkage of Xerogel based EFB. In methodology, it was divided into three sections. The first section is the preparation of EFB. The size of raw EFB was reduced by using constant speed mixer and ball milling. In second section, it involved the preparation of standard Xerogel. 50 ml of distilled water is poured into a beaker and stirred by using a magnetic stirrer with hot plate. Then, sodium alginate is weighed and added in the beaker until it homogenized. Next, calcium carbonate is weighed and added into the homogenized solution. Then, turn off the heater and EFB is mixed in the solution for 10 minutes. After that, GDL is added into a mixing solution for 30 seconds. Then, the mixing solution was transferred into ice cube tray with equal proportion. Next, ice cube tray was placed in the freezer for 24 hours. Then the hydrogel was placed into the conventional oven with a constant temperature at 60 degrees for 24 hours. And note that the experiment was repeated by using different weight of GDL and EFB. In the next methodology is the characterization of Xerogel, which are SEM, FTIR, TGA, BET and XRD. For SEM, it based on ASTM E766/14 with modification from Rodriguez Dorado 2019. The samples is splatter coated with a platinum and image is taken from 50 to 300 magnification for each samples. Then FTIR is based on ASTM D6348/12E1 with modification. The spectra is taken by using Perkin-Elmer spectrum 2000 in the range from 600 to 4000 cm of wavelength. While for TGA, it based on ASTM E10131/20 based on Nur Hayati Abdullah with modification. The samples is heated to 900 degree with 10 degree per minute under nitrogen gas. Air is introduced after 900 degree with a velocity 25 milliliter per minute. And it followed by BET, which based on ASTM D4567/19 with modification. This was performed at 77 Kelvin by using model 3 flags and degas at 60 degree under a vacuum. Lastly, for XRD, it based on ASTM D934/13 and Sudiana 2016 with modification. XRT patterns is recorded at ambient temperature with a diffraction angle range between 5 to 60 degree 2 theta with a step size of 0.052 theta for 25 minutes. In last section is the adsorption of engine oil. The first one is the preparation of 15 ml engine oil, then the weight of Xerogel before adsorption is taken. Next, Xerogel is immersed in an engine oil for 15 minutes. After that, Xerogel is transferred into a sieve net for 30 seconds. Then, the weight of Xerogel had been immersed in engine oil is taken, and lastly, for one sample is tested for 3 times to take average rate of adsorption. Next, I will proceed into result and discussion, which consists of characterization, Xerogel, and adsorption of engine oil and percent shrinkage of Xerogel. In this figure shows the TGA curve for raw EFB, Xerogel, and blank alginate. The TGA curve is used to compare the thermal stability of the sample and was separated into 3 regions. The first region is a moisture content, while in second region is a voltammeter, and the last region is a fixed carbon. In the first region, the raw EFB was observed to release high moisture content comparing to blank alginate and Xerogel. For second region, the blank alginate experienced the first degradation due to the release large amount of voltammeter and followed by sample of Xerogel and raw EFB. This can be explained that the alginate released high amount of hydroxyl groups and alginate backbone was breaking along increasing in the temperature. Besides, the release of carboxylate groups caused alginate to lose its weight at temperature 700 and produce carbon dioxide. While in the third region was observed the similar degradation for all samples occur at the temperature 900 degree. In this table is the TGA analysis for all samples which determine the approximate results on percentage of moisture, volatile, fixed carbon, and ash. From the results, it was observed that the Xerogel EFB shows in increasing the trend of moisture content and voltammeter from raw EFB due to the internal gelation method and drying process. Then, the fixed carbon also increased from raw EFB with 21.92% to Xerogel EFB with 30.64% along increasing in the temperature. This is due to the lignocellulose cell in a biomass which undergo decomposition and devolatilization reaction, which results in increase of fixed carbon. This table it shows the surface area, total pore volume, and pore size for all samples from Brunner Image Taylor BET analysis, which employ with nitrogen gas at 77 Kelvin. And the results from BET analysis is used to compare the blank alginate and raw EFB with standard ratio of Xerogel. From the table, it was observed that the blank Xerogel and raw EFB are higher in a surface area comparing to standard ratio of Xerogel because of the internal gelation process which reduced the Xerogel surface area. Next is the pore volume of standard Xerogel is noticed as the highest comparing to other samples due to the proper mixing between raw EFB and alginate. The results from BET analysis also shows the effect of chemical use, which is empty fruit bunch and Glucono Delta-Lactone (GDL). From the table, it shows by the adding more empty fruit bunch from standard ratio of Xerogel, it results in the higher of surface area, pore volume, and decrease in the pore size, which leads to higher adsorption capacity. Meanwhile, by addition or lessons of GDL from standard value, both display the increasing in a surface area and a pore volume but decreasing in a pore size. The addition of GDL shows the higher adsorption capacity comparing to the lessons of GDL. Scanning electron microscopy (SEM) is used in this study to characterize the porous material through analysis surface morphology for raw EFB, blank Xerogel, and Xerogel EFB. Any discharge ion is removed to prevent the interruption of the analysis process by sputter-coated the sample with platinum at a pressure 2 megapascal for 1 minute. In a plate 4.4a, it shows the EFB fiber structure, while in a plate 4.4b, it shows the flat surface and homogeneous structure of blank alginate Xerogel. And plate 4.4c, it displays the combination from raw EFB and blank Xerogel, which has fibrous structure and smooth surface. The morphology of Xerogel EFB, it shows the brittle structure and consists network strands of EFB fiber which connected to pores. In XRD analysis, the diffraction pattern is between raw empty fruit bunch and Xerogel empty fruit bunch. From the results, it was observed that both of the diffraction pattern shows peak of 2 theta at 15 to 22 degree, which represents the cellulose 1 and lignin structure. Then, the sharp peak of raw EFB was noticed at 2 theta equal to 22.17 degree, results in the presence of crystal structure of cellulose. Lastly, the diffraction pattern of Xerogel empty fruit bunch. It shows broad peak at 2 theta equal to 22.29 degree, which means the Xerogel of empty fruit bunch was no longer crystalline. Thus, the internal gelation process, which involved the combination of chemical use and empty fruit bunch, produced amorphous Xerogel empty fruit bunch. FTIR analysis were used in this study to identify the functional groups of raw empty fruit bunch and Xerogel empty fruit bunch. From the results, it was observed that the OH stretching is present in the raw EFB, which shows by the spectrum of broad characteristic peak at 3335.92 cm, while OH group was disappear in a Xerogel EFB due to the drying method, which caused mass loss of Xerogel empty fruit bunch. Lastly is the presence of C double bond O stretching at 1735 cm in a Xerogel empty fruit bunch, which represents the presence of hemicellulose and lignin but not present in a raw EFB. In this figure illustrated the effect of empty fruit bunch on adsorption of engine oil and percentage shrinkage. Based on figure, the addition in the amount of empty fruit bunch, it results in the increasing the adsorption capacity of engine oil and decrease the percentage shrinkage. With relations on BET results, the increasing the amount of EFB increased the surface area and pore volume, and it caused the decreasing in the percentage shrinkage of adsorbent Xerogel. In this figure, it shows the effect of GDL in percentage shrinkage and adsorption capacity. The effect of GDL concentration is various in the presence of constant calcium carbonate. In this figure, the addition in the amount of GDL increased the adsorption capacity of engine oil and decreased the percentage shrinkage. Based in PAX 2014, the amount of GDL must be twice than calcium carbonate to ensure the complete release of calcium ion by GDL for cross-link to occur. In conclusion, the synthesis of Xerogel-based EFB was successfully carried out. The results from characterization of SEM, BET, XRD, TGA, and FTIR, it shows that Xerogel-based EFB consists of a fibrillar network and a smooth surface. And the fixed carbon was also noticed increased from raw EFB with 21.92% to Xerogel EFB with 30.64%. And the diffraction pattern of Xerogel EFB, it shows broad peak at 2 theta equal to 22.9 degree, which indicate amorphous material. And the surface area of standard Xerogel is 3.06 meter square per gram. Lastly, is by increasing the amount of empty fruit bunch, the adsorption capacity is indirectly proportional to a percent shrinkage, and the highest adsorption capacity and percent shrinkage of Xerogel EFB is 0.67 and 85.15%. Prior from this experiment, it is recommended for the next researcher to use different types of drying equipment such as microwave. Microwave, it can provide fast drying compared to oven drying, as well as it saves energy compared to conventional hot air drying. Microwaves, it penetrate to the interior of the adsorbent and heated the water within the adsorbent. This will allow the fast removal of moisture from the Xerogel. Next, it is recommended to extract the cellulose from empty fruit bunch, as cellulose play important role in the adsorption of engine oil. Highlight, this paper has been submitted to the Journal of Environmental Chemical Engineering Q1 paper. Last but not least, I would like to express my special thanks of gratitude to my supervisor, Professor Dr. Azil Bahari Alias, and our coordinator for research project, who gave me the opportunity to do this wonderful project. And I would like to thank to my parents and friends, especially to Nick Faisal, who really helped me a lot in finishing this project within the limited time. And I am really thankful to them. That's all from me. Thank you also to examiner for evaluating my poster presentation. That's all. Thank you.